So the TensorFlow 2 will be easier to learn, but the TensorFlow 1 have, maybe faster than the TensorFlow 2. Yeah, but there's a lot of grammar in TensorFlow 1, so yeah, I will talk about it. So you only need to know the TensorFlow is for deep learning. Actually, you can also train some traditional machine learning model, just like the linear regression model with the TensorFlow. So do you have any question about the TensorFlow? Hello, my friends.
Which one is dynamic and which one is static?
Okay, I will talk later. So yeah, the static means we have to build the computer graph before we run the program, and yeah, it is a little bit complex. So yeah, you only need to remember we cannot use the code in TensorFlow 1 to the TensorFlow 2. That means the code of the TensorFlow 1 and the TensorFlow 2 are totally different. Okay. Yeah, actually, when we develop the projects of the deep learning, we usually use the TensorFlow 1 because it's faster with the static computer graph, and you will find that there's no TensorFlow 2 environment in Huawei Cloud. And by the way, you can log in the Huawei Cloud now, and later we will talk about the experiment. Okay. Yeah, there's a simple quiz. The TensorFlow is a frame designed for deep learning. So, do you think so?
True.
Yeah, that is true. Absolutely. Yes, it's true. Okay. And then, yeah, the next part, I will talk about the TensorFlow basics. Yeah, the TensorFlow grammar is a little bit different with the Python, and there's some features that is difficult to understand. But the first thing I want to say, the TensorFlow is tensor concatenates the flow. So what is a tensor? Actually, all the shape of the data in TensorFlow are tensor. So the tensor means we can build the n-dimensional tensor. The n can be 0, can be 1, can be 2, can be 3 or more. And the 0-dimensional tensor means that is the scalar or number. Yeah, there's number, maybe the same. So 0-dimensional tensor is a scalar or a number. So 1-dimensional tensor is a vector. Just like the original list like this. Yeah, that is a 1-dimensional tensor. And so you can guess the 2-dimensional tensor. What is a 2-dimensional tensor? Zero is a scalar, and 1 means the vector. So what is a 2-dimensional tensor?
Matrix.
Yes, exactly. Thank you so much. Yeah, so the two-dimensional tensor is the matrix. Okay, and yeah, the n can be more. So that is a tensor. And another one called the flow. That means data flow graph, or we can call it a computing graph. So that is the example of the data flow graph. Yeah, it is an example here. So the x here equal to 8. So what is the type of the x here?
Scalar.
Yeah, that is a scalar, so it is a zero-dimensional tensor, right? Okay, so that is the y, and we can multiply the x and y, and we will get the z. This is a simple computer graph. So the z rely on the x and the y, and that is a endpoint of the graph. So if we hope to calculate z, and we need to calculate the x and the y, that is the computer graph. So, and in TensorFlow 1, we have to use the session to run all the computer graph. So we have to use the session.run, and I will tell you what is the session later. Okay, that is a TensorFlow. And here, the first one called the tensor, and the tensor is a data shape, yeah, data type, and yeah. And the second one called the session means if we do any computing, we need to use the session in TensorFlow 1. Can you understand? So if we hope to calculate the C equal to A plus B, we have to build or create a session, and then we can calculate the C. So just remember. And the third one called the graph, the computer graph. So there's a node, there's a edge. So yeah, in this one, in this graph, the Z is the end node. Okay, and the next one called the operation. So if we do any operation, we need to build a session. Okay, and the last one is the variable. The variable in TensorFlow 1 is, yeah, it's different with the Python. We need to definition a variable, and after definition, we also need to initialize all the variable, and then we can use a variable. So that is the difference with the Python. Okay, the variable I will show you later. And yeah, do you just loading the Huawei Cloud? And please start the notebook, and then we can do the experiment. I will show you the session, and I will show you the tensor. What is a tensor? Okay, here. In each data, we always use a tensor to indicate the data. And in one tensor, there's a 3 attributes. The first one called the name, just like the name of the person. And then the second one called the shape, just the n-dimensional tensor. So that is n, or yeah, and not only n, but the shape. So if the n equal to 0, the shape will be empty. And For example, the n equal to 1, maybe it will be 2, like this. It means there are 2 elements in one vector. Okay, and the last attribute called the type. It's just like the type in Python, but for example, in Python, we know there's a type called float. That is a number. Do you still remember it?
Yes.
Yeah, but in TensorFlow, it will be tf float. The tf means the TensorFlow. So it is some difference with the Python. So the name, shape, and the type, I will show you.
What kernel are we using if we open it up on the cloud? Is it 1.13 or 1.8 TensorFlow?
You can use the 1.13. Yeah, in this course, you can use the 1.13. Okay. So okay, can you see my crowd? There are 1, 2, 3. Oh, only 3. Okay, just wait a minute. So please log in the Huawei Cloud now, and let's do some experiment. Okay, so do you remember how to log in the Huawei Cloud?
Yes.
Okay.
No.
So if you forget, just follow me and click here. Please mute. Okay, so please click here, log in, and yeah, select here, I am user login. So can you follow me?
Yes.
Yeah, thank you. And input your account name and I'm username and the password. Or the account name is Sunrise HP. And I am user 48. And the password is A123456. Just like this. and then we can log in. Okay, so do you log in? Finish it?
Yes.
Okay, so click here, model us, and
Sorry, where did you
select
click?
here in the home page, this button, the model us. And then click here, try now.
Okay, my computer is a bit slow.
Okay, so just wait some minutes. And then if you enter this page, remember select the environment here and enter the notebooks. And it will need the access key, just cancel it. Okay, I think. So let's go back to the slides. Wait for other students. Okay, so the tensor are n-dimensional data. So the n can be 0, 1, 2, 3, 4. And in the, actually, we were code in the examination. So there are some contents about the Python and the TensorFlow. But you don't need to use the TensorFlow to build a neural network, but just some basic operation like define the variables and multiply to matrix like this. And yeah, that is the first one I want to introduce. That is a tensor. Very important content in TensorFlow. And then that is a session. So do you still remember what is a session?
Yes.
Please. So can you just describe what time or when we need to use the session?
If we need to do any,
Go
Sorry?
ahead.
Sorry?
if we need to do any operation, we need to create a session.
Yeah, exactly. So I will show you. Now, if we want to know the value of C, and we can just use session .run C and print the result of the C. And then that is a computer graph. If we need to get the C right on the B here, and W here, and the X here. So if we need to get the C, we need to calculate the B, W, and X. And here, we can think the W and the X are the matrix, and after multiply these two matrices, and we will get a new matrix. And here we will add the B is another matrix, and then we will input the result into the ReLU activation function. So we will talk about the ReLU in the deep learning part, and then we can ignore the ReLU here. Just think we will get the C. So the C rely on the B, W, and X. And when we session the run C, and we will calculate the B, W, and X. That is the session. Okay, and how to feed the data in TensorFlow? There is one method called TF-door placeholder. That means hold a place, but not input the data directly. So we will define TF-door placeholder. If you can understand, just think, I hope to eat dinner in one restaurant, and now I'm teaching, so I just booked the restaurant now, but I will not eat the dinner this time. And after the course, maybe I will go to the restaurant to eat dinner. So that means book a restaurant just occupied one desks, for example here. That means I will tell you we need some data when we do the operation. So that is a TF-door placeholder. And when we run the session, for example, session.run, and then we will feed, for example, feed dictionary. And then when we run the session, we will feed the datasets. The datasets definition by the TF-door placeholder. Okay, so it's a little bit complex. And the variables. Yeah, in Python, when we create variables, we only need to, for example, we don't need to define the variables. So do you agree? In C language, in C language, we need to define a variable just like int a equal to 1. Yeah, just like this. And in TensorFlow, we also need to define the variables. Blah 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 blah. And then after define the variables, we need to initialize all the variables use, for example, TF-door global. Initialize variables, use this function. So I will show you. That is quite complex. Okay, so do you start your notebook now?
Yes.
Okay, so let's start. Open the notebook and you will find there's a Jupyter file named TensorFlow experiment. So we can open this file.
Which is 1.13 or 1.8?
Sorry. I will
1.18,
yeah,
I think.
1.13. Yeah, 1.13. Where's mine?
Sorry, my environment has been starting forever. It's not finishing to start. What could be the problem? That's 45.
Same applies to mine.
So you are the 45?
Yes, it's just starting and been running that way for a long time.
Okay, so you can start the 46.
Okay.
I'm using 46. It says no data.
Oh, you can. Okay, you can start the 47 maybe. Just choose another one.
Okay, let me try because this is running forever.
Yeah, I
If
know.
it says no data available, what does it mean?
Sorry?
No data available. I have notebooks in front of me, but there's nothing else. Just says no data available.
I think he hasn't selected Beijing 4. He has to select Beijing 4. Maybe that's
Yeah,
why.
here we need to choose the Beijing 4 here.
Okay.
Yeah, so can you find all the notebooks now?
There's no Beijing 4 there. Is it? Okay, I see. CN not Beijing 4.
CN North Beijing 4.
Okay, thank you.
Yeah, you're welcome. So can you see
Hello?
all the notebooks?
Hello?
Hello?
Yeah, mine also is taking long to start. It's now user 17.
Sorry, your voice is a little bit.
User 17.
Can you speak louder? Yeah,
17.
1.13.
1
Yes.
7.
1.7.
Yes.
1.7. Okay, so you're 1.7. Yeah, so you cannot start the notebook, right? You can choose the 1.7. Okay, you can choose another one. For example, 1.8.
Okay, thank you.
Yeah, you are welcome. There's sometimes
Also,
yeah.
Hello. Also, mine user 6.
User 6.
Yeah. It's still
Yeah, you can choose user 5 maybe, or user 7. Yeah,
Okay.
just choose another one.
Okay.
I'm sorry about it. There's maybe some bugs in Hoi Cloud. We start too many notebooks in one content, one account, sorry. And yeah, I will show you the experiment now. Yeah, please select the kernel here. You can select the kernel, change the kernel to TensorFlow 1.13 version. Okay, and just follow me. That is the first cell for the TensorFlow, the first cell. And yeah, we only want to print the hello TensorFlow. So the hello is the constant. We also need to define that constant. Okay, so yeah, can you see that?
Yes.
The hello, we need to define the hello is the constant. So what type of the constant? Can you tell me?
A string?
String.
Yes, it's a string, but in TensorFlow, it is a TF-door string. Okay, I will show you. We can also print the hello directly. And we don't need them.
Could you make it a little bit larger?
Okay, that is a string. Sorry, there's no TF-string in TensorFlow 1. That is a string, but there's a TF-door float and TF-door int, just like this. Do you still remember the three contributes in Tensor? The first one called the name. And the second one is a shape. So what is the shape of the hello?
Zero dimension.
So yeah, exactly, 0 dimension. Okay, so that we can see that is a scalar. Okay, and here, that is a D type. We can see, okay, that is a type, and it is a string. Exactly, that is string. But we cannot print hello TensorFlow, right? We cannot print hello TensorFlow. We can only, that is a tensor, and that is the name of the tensor, the type of the tensor. So if we want to print the hello, what should we do? So can you tell me how to print the hello TensorFlow? What should we do before we print the hello TensorFlow?
No.
We change TF to string first.
Change TF.
TF constant to TF string.
Do we have to call the name attribute of hello?
We can print the name of the hello just like this.
Yes.
Yeah, but yeah, just try. It will only print the name.
Mm-hmm.
So how to print the hello TensorFlow? The content in hello. Do you still remember if we hope to do any operation, we need to create a session. So we need to create a session here, just like this. The session equal to tf.session. That's very important. And then if we want to print hello, we need to run the session just like this. Print session.run and put the hello into the session.run function. And after print the session.run, we need to close the session, just like the file operation in Python or C language. So do you still remember the file operation? Just like f.open, f.close. So after finish operation, we need to close the file, and here we also need to close the session. So we need to use session.close, and then we can print the contents in hello. For example, here, hello TensorFlow. Okay.
What's the B for?
B.
Yes.
You can change another way. For example, here, print hello. Oh, sorry. No, sorry. Oh, we can only put the print outside. But in TensorFlow 2, you don't need the session, and you only need to print hello. It's fine. So it's quite complex to understand. The B means.
So can you use a single session to run multiple operations?
Sorry, excuse me?
Can you use a single session to run multiple operations?
No, sorry, you should to use a lot of session, just like here. For example, here, you need to run the initialize. So we initialize the variables, and we need to run the initialize, and then we need to run the optimizer to train the model. So we need to run a lot of sessions. But there's another way to run the session, just like here. We can use the ways to run the session. And then after run the session, we don't need to close the session here because it will close automatically. That is another way to run the session. So can you understand why we need the session? So here the B means it is a string, but not okay. Let's try another way. For example, we can decode it, and then it will be the original string. So can you understand it? Maybe not. So do you know how the computer store the data?
Machine language?
Not exactly. So when the computer store the data, we need to put we need to change the string to some typical characters like
binary and hexadecimal and the like.
Sorry?
I mean the binary and hexadecimal for the computer to understand.
Yes, there's a table to store all the characters. So that called
HCIA.
ASCII.
ASCII.
Yeah, exactly. So if we want to get the original one, we need to use the decode. So can you understand? That is a that is a string. So we need to decode it.
Okay.
Yeah, thank you. And yeah, there's another way to create a session. Use the ways tf.session as session, and then we can run a lot of session here. For example, we can run A plus B or A multiply B. We can calculate them in one. For example, that is we can see that is a space. We can put all the session into the ways, and then we can calculate all the session or the operation. Yeah, there's another example. That is a list, and that is a big list. And in the big list, there are two sublists. So can you tell me what is the shape of the C?
It's 2.
Yeah, exactly. It's a two-dimensional tensor.
It's a vector.
So yeah, it is a vector. No, that it is a matrix.
Matrix, okay, yeah, sorry.
Yes. Okay, so that is a matrix. We can print the C like this. Yeah. So the name of the C is const 9. So we have defined 9 const in this program. So they're called 9. And here the 0, yeah, the 0 means no meaning. Oh, it will add or the name to 0. I don't know why. Okay, and here, that is the shape of the C. It's 2 by 2. That means it is a matrix. If it is a vector, maybe it will be 2. And here, we don't need this 2. We can just try it. Yeah, can define an E. And print E here. Okay, just like this, the shape of the E is 2. So that means it is a vector, right? And there are 2 elements in this vector. And that is a type. So yeah, the type of the E is string 32. I don't know why it is not tf.string, tf.int. Actually, if we use the tf.constant to define the one constant, it will, the D type will be tf.int 32. Maybe that is the difference between TensorFlow 1 and TensorFlow 2. Okay, so if we hope to calculate the, if we hope to calculate the A plus B, we cannot print here, just like we cannot print the content in hello, we need to create a session. So you have to remember we need a session here and use a print, just like add. Do you still remember what's the meaning of the %d?
Yeah, integer.
Yeah, that is the int. So we can just, yeah, show print the A plus B. Okay. Let's try it. Yes, the A is 3 and the B is 4. And A plus B is equal to 7 and A multiplied B is equal to 12. Okay. And that is a session. So do you understand what is the session?
Yes.
Okay, thank you so much. And another one, I will show you the variables. Yeah. Just find the linear regression. And here, we define 2 variables here. The W means the weight and the B means the bias. And we will come back to this experiment after introduce a linear regression model. But here we only need to know, after define the variables, we need to, look at here, initialize all the variables. So we need to use tf.global variables initializer, this function, to initialize all the variables. And of course, if we hope to operate, execute this function, we need to create the session. and use the session.run to initialize the variables. So can you understand it? It's quite difficult to understand. It's not friendly to, to a rookie that is the first time to build a neural network, you use the TensorFlow 1. But in deep learning part, I will introduce, there's another method called, another framework called Keras. So if we use the Keras, it will be more easier. But unfortunately, we will code the TensorFlow in the examination. So you should to remember it. We need to initialize all the variables. Yeah, can you understand it? After define the variables, and then we need to initialize all the variables, then we can just use the variables. Okay. That is another thing I want to introduce. And then I hope to tell about the placeholder. Yes, it is a placeholder. So here, just like book a restaurant, we will tell the X, oh, remember we need this type of the data set. And just remember it, just book it, and then when we run a session here, we need to feed all the data set. For example, here we use a dictionary, and X, that is X here, we need to use train X. The train X is here. That is the area of the apartment. And that is the Y is the value of the apartment. We also need to feed the Y, feed train Y into the Y. And then we can train the model. So can you understand what is a placeholder?
Yep. Okay.
Yeah, thank you. So that is what I want to talk about. So there's a quiz. I will share. Oh, sorry. Yeah, there's a quiz.
Sure.
Yes, exactly. So you need to remember, we need to build a session before any operation. So that is true. Okay, and there are a lot of modules in TensorFlow. That is why we need to use the TensorFlow. For example, it's very hard to implement the gradient descent algorithm, but in TensorFlow, there is the optimizer. So we can define an optimizer, use only one line, one method to define the optimizer. So there's a lot of functions. I will not tell the details of these modules. If you are interested about these modules, you can just Google the TensorFlow and into the website. In the main page, you can find any functions you want. For example, if you want to build a convolutional layer, you can use tf.nn.com2d and then build a convolutional layer. You can also use tf.layers to build a convolutional layers. They're similar, but the TF layers it's easier to use. So there are a lot of modules in TensorFlow. I will not tell you the details. But in the deep learning part, we will implement implement the convolutional neural network. Okay, and I will also show you how to use the carriers to build a generative adversarial net. So it's fine. I skip this part. Okay, the last part I want to introduce is other deep learning frameworks. For example, now we have a lot of framework. So do you hear about any of them? Maybe not.
I haven't heard of any of them.
Okay, so
I have not
here.
heard of any of these.
Okay, it's fine. It's fine. No problem. If you are interested about the deep learning, I suggest to use the carriers, but the carriers rely on TensorFlow. So we have to install the TensorFlow in your laptop or computer, and then install the carriers, and then you can use the carriers. So the carriers use TensorFlow's backend. That means we have to install the TensorFlow before we use the carriers. Okay, but the carriers is easier to understand and use. Okay, and here that is another famous framework called Torch. The Torch rely on another language, but in Python it is called PyTorch. So the PyTorch, just like the TensorFlow 2, it uses a dynamic computer graph and easy to understand, easy to code, but the speed of the PyTorch and TensorFlow 2 will be slowly. Yeah. Okay, that is some attributes of the framework. You can see here, the TensorFlow is the C++ core. That is why the TensorFlow just like the C language, but not the Python. We need to define the constant and the variables. Okay, and attention here, the TensorFlow, we can install the CPU version or the GPU version. If you have the NVIDIA GPU, just like 1080 or 2080, and you can install the TensorFlow GPU version. But the CPU version and the GPU version are different. So you can use the pipe install TensorFlow. Sorry. To install the CPU version. But if you want to install the GPU version, you need to add dash GPU to install the GPU version. And if you have the GPU, you can train the models quickly. But you have to, you need to use the NVIDIA GPU. So do you know the NVIDIA? Okay, okay, thank you. So before you install the GPU version, you need to install other two things. One called CUDA and another one called cuDN. And you need to overwrite the files in cuDN into the CUDA, and then you can use the GPU version. So that is very complex. But if you use the Huawei Cloud, you can just log in with your account and create a new notebooks with the GPU version. And then you don't need to install the CUDA and the cuDN. And then you can use the GPU version. That is easy to use if you use the Huawei Cloud. And I remember now there's a free GPU version TensorFlow notebook, So you can create your own account and try to use the GPU version TensorFlow. And maybe after class, use the same code in this course. You can compare the speed of the CPU version and the GPU version. Okay, so there's a simple quiz. The CPU version and GPU version of TensorFlow are separate. So do you think so?
Yes.
Yes, that is. Okay, it's true. And yeah, the last quiz for the TensorFlow. Which of the following application scenario of TensorFlow?
B.
B.
Oh.
Yes, that is a multi-choice. So all of them. So the AlphaGo use deep learning technique. So the AlphaGo, we can also use the TensorFlow to implement the AlphaGo. And of course, the face recognition. And that is, called style transfer. We can use the cycle gain. There's a typical neural network. The name is cycle gain. And we can use the cycle gain to transfer the style. Includes the image style or the voice style, just like change the man to a woman. And last, self-driving. Yes, that is because it used reinforcement learning to train a neural network. So we can also use the TensorFlow to implement the self-driving. But that is a software. You should know it. We cannot create the car. Okay, so do you have any question about the TensorFlow?
Yes, I have.
Yes, please.
I would like to know some difference between TensorFlow and R language.
The TensorFlow is not the language you need to know. That is just a library in Python or the framework. But if you want to know the difference, that is a difference. But I don't think you're interested about the difference. For example, the core language of the TensorFlow is C++, but the torch is the Luna, and the PyTorch is Python. Okay, and there's another framework called Caffe.
Okay, for example, I would like to know if inside the TensorFlow can support the R language.
Yes, the TensorFlow, we always use a Python, and the TensorFlow is only used in Python. So you cannot use the TensorFlow in other language. that is a library in Python. But TensorFlow, yeah, how to implement the TensorFlow functions, the Google company used the C++ language. Okay. Can you understand?
Okay, I'm good.
Yeah, so do you have any questions? So,
So TensorFlow, is it more like MATLAB?
you mean the MATLAB?
Yeah. How does it compare? Yeah, how does it compare?
Yeah, you can also use the MATLAB to build neural networks. But actually,
which one is better between MATLAB and TensorFlow in your view?
If you want to process the images, I suggest you use the MATLAB because there are a lot of functions in images. But if you want to build a very complex neural networks, I will tell you in deep learning part, there are a lot of kinds of neural networks, including the convolutional neural network, the recurrent neural network, and long short-term memory neural network, and generative adversarial network. It's better to use the TensorFlow because it's designed for deep learning, but the MATLAB is not designed for the deep learning. So the TensorFlow is powerful.
Okay, thank you.
Okay, you're welcome. So let's take a break for 10 minutes and come back at 16. So do you agree?
So while we just, excuse me.
So do you agree?
Yes. I agree.
Yes.
Okay, thank you. So, sorry?
I wanted to ask. Okay.
Yeah, please.
Yes, I see TensorFlow and the rest of these, Cafe, Neon, Piano, Touch. Other than TensorFlow, which other one comes closer to TensorFlow in case I should have an alternative?
Actually, if you do want to use a TensorFlow, you can use a PyTorch. That is just similar with the torch, but the core use a Python language. So yeah, you can use the PyTorch. It's also easy to use. Yeah, the PyTorch is very close to the TensorFlow 2, the second version of the TensorFlow. So you can also use a PyTorch. But I suggest you use the Keras. That is easy to use. And I will show you how to use the Keras in deep learning part. Okay.
So Keras is different from TensorFlow.
Yes, the Keras use
they do the same thing.
The Keras is a simple function of the TensorFlow. The Keras use a
Keras is a
back
framework
end.
of TensorFlow.
That is a framework. Of course, the Keras is a framework, but it relies on the TensorFlow. So you can think the Keras is a simple way to implement the neural network. But we also need to install the TensorFlow. It uses the back end of the TensorFlow.
Other than that, other than the Keras, which other alternative could be closer to the Keras and could be open source?
The Keras is open source, and the TensorFlow is also open source, and the PyTorch is also open source. So you can choose one framework. But if you want to, pass examination later, you need to code the TensorFlow.
Which one does Huawei use?
the while we use our own framework, it's called -4. Yeah. The -4 is Huawei's framework, but actually a lot of people use the TensorFlow. So the TensorFlow is the most popular framework. Okay.
So the -4 uses Python as well?
You mean the -4? Yes, it uses Python, but actually it can only use in Linux system now. So if you are a Windows system, you cannot use -4 now. But maybe next year, you can also use the -4 in Windows system. So do you have any question? Yeah, you are welcome. So okay. We will go back. Yeah, 11:16, okay. Maybe later, 20, okay. Yeah, and then we will talk about the machine learning.
Okay.
So do you come back?
Yes.
Okay, thank you. And there's a mistake I mentioned before. Actually, the TensorFlow 1, we can also use in the C++ language or Java language. But in TensorFlow 2, we cannot use the TensorFlow 2 in the C++ and the Java. Okay, we can, we can only use the TensorFlow 2 in Python or R language. So do you know what is R language? Maybe hear about
R.
R, yes.
Yes.
Okay, so that is a different. I have a mistake before. So let's continue to introduce machine learning and deep learning. So do you still remember the relationship between the machine learning and the deep learning?
Pardon?
Sorry, can you speak louder?
One of them is a subset of the other.
Yes, so
deep learning is the subset of machine language.
Yes, exactly. So the deep learning is neural networks, and yeah, in machine learning there are other algorithms, other models, just like linear regression and decision tree and so on. So first, we need to learn something about the machine learning, and that's both same contents, same in deep learning. So do you know what is a machine learning? What is the machine learning, or what does a machine learning model do? Yeah, you can see this page.
Is it the machine learning deals with algorithms? I mean, they are basically deals with algorithms.
The machine learning is an algorithm. A machine learning model, you can think that as an algorithm, but can you tell me how to use how the algorithm do, or what is the difference between the machine learning model and with other algorithms?
I think it feeds the data from the data sets.
Yes.
It gets Yeah, which is actually, those data sets are comprised from deep learning.
Yes, okay. Yeah, so the data is very important part in machine learning. So the machine learning is learn the experience from the data. So the machine learning model learn the experience from the data, just like find some regularities in the training data, and then the machine learning model can predict the new data when we feed the new, the new features of the data, just like this. So that is a machine learning model. Do it make sense or have some questions? Actually, now one machine learning model can only use in one task. That is, that is a limitation. That is a weak AI. So the machine learning algorithm can only do one task, just like the AlphaGo can only play the Go, but cannot drive the car like this. Okay. So just like the human, when we, for example, after the course, we need to do the examination. How to improve the score in the examination? Can you give some suggestions?
You read more stuff, you read more books, you practice more.
Yes.
You find out what you did wrong the last time and then improve.
Yes, exactly. So we need to practice more or see the video again like this. And then we have more experience of how to do the examination. So the machine learning model will also get some experience of find the regularities from the training data and then do the prediction on the new data. That is the machine learning model too. Okay, can you understand? That's very important. So we need a data set when we train a machine learning model. And we will divide the data set into training set and the test set. So we only use the training set to train the machine learning model. That is the old data. Old one, we need to find some regularities in the training set, the training data, the old data. And when we feed on the new data, we can call it the test set. And the machine learning model never see the new data, and it will predict the output. So can you understand the training set and the test set?
Yes.
Okay, thank you. So there's a problem called overfitting problem. So we need to understand what is a underfitting and what is a overfitting. So the understand underfitting means the machine learning model cannot learn the features in the data set, so it cannot find the regularities. And its performance bad in training set. Just like the point means the datas, and the line is the machine learning model. So this line cannot indicate the data. So they're called underfitting. That means the machine learning model performance bad in training set. The model is too simple, but the features of the data are too complex. It's called underfitting. And that is a perfect model, just like this. And the overfitting means the machine learning model learn very well in training set, and it can fit all the training set, but it cannot perform very well in test set. When we feed a new data, the prediction will be not so good. It's called the overfitting. So the model is too complex, but the data is the number of the data is too small, and then it will cause the overfitting. So it performs very well in training set. Training, oh good, but test, no, not so good. That is overfitting. So can you understand?
Yes.
Okay. Do you have any question about the underfitting and the overfitting? I have a question. Why, when the machine learning model performs very well in training set, it will cause overfitting? So can you think about this question? So why this line will overfit? Yeah, there's an example. For example, in image recognition task. So do you know the image recognition task?
Yes.
Yeah. So for example, there's one of the data and one for the image, and it is the image of the human. So there's a human. That is a subject of the image. But in this image, in the background, maybe there is a tree, a small tree. So do you like my drawing?
Yes.
Okay, there's a tree in the background. So, but the label, so the ground truth answer of this image is belongs to the human. So the probability of the human is 100%, that means. But actually, it's better to use human, for example, 80%, and the tree, 20%. I think this answer is better. But actually, we always have one label. That means it only belongs to one class. So that is a picture of the human. So the label is a human. But actually, maybe it also have the tree. So if we learn the training set very, very well, and the machine learning model will think, oh, maybe the tree is also a human. That is why it will overfit. It just remember the answer, but not understand why that is a human. Just like when we do the examination, we just remember the answer of all the questions, but when there's a new question here, we cannot do it very well. That is the overfitting problem. Okay, can you understand?
Yes.
Okay, thank you. So if we have a lot of data, a lot of images, for example, and there's a car how to draw the car. Like this. The car and also a tree, but this photo belongs to the car, for example, and the machine learning will find the regularities that whether the background had a tree, yeah, the answer will not influence, will be not influenced. So that means if we have a lot of data sets, we can avoid the overfitting problem. But if the number of the data sets is more and the machine learning model is learn the training set too well, and it will cause the overfitting problem. Okay, but the reason of the overfitting problem have a lot of reasons. So that's one of the reasons. Okay, and let's see the process of the machine learning. So there are six steps, and just like, do you know how to cook the vegetable? The vegetables, how to cook it?
Yes.
Okay, so when we implement the machine learning model, just like cook a vegetable, the first step, we need to collect the data. Of course, we need the data set in machine learning. So we need to collect the data, just like we buy the vegetables in the supermarket, and it is similar. And then we need to clean the data, because, for example, in the table, there are a lot of rows, means a lot of data. And the features here, for example, the table means the features of the human, and it is the age, height, and the weight, for example. And in some rows, maybe the height or weight, we have no height or no weight. And that means it's the dirty data. And if the number of the data is very big, we can just delete this row. We don't need to use this data. That means we clean the data. Okay, can you understand? In the data sets, not all the data can be used. So we need to clean the data, just like we need to wash the vegetables before we cook. Okay. So the next step called feature selection. Feature selection. Just like there are a lot of features of the human, but we don't need to use all of them, but just select some of them. That's called feature selection. Just like after wash the vegetables, we need to cut the vegetables. I'm not a good cook, so I'm not good at cutting. Okay, so this step called feature selection can make sense?
Yes.
Okay, thank you. So the next step called training model. So in this step, we need to train a model. But first, we need to see the performance of the training set. The performance of the model in training set. If the performance not so good is bad, what's the problem? If the performance of model in training set is bad, what is the problem?
Maybe the network is not appropriate. The type of network.
Actually, it called underfitting, right? It's underfitting. That means in training set, the model performance bad, even in training set. They called underfitting. Okay. Yeah, can you understand?
Yes.
So we need to check the performance in training set first. And then we need to check the performance of the model in tested set, called model evaluation. So if now, yeah, the model performance very good in training set, but performance bad in testing set, so what's the problem?
Overfitting.
Overfitting now.
Yeah, exactly. Thank you. Overfitting problem. So can you understand? That is a step. But if we find the overfitting problem, what should we do? Yeah, we should come back. Just like we don't know what's the problem cause the overfitting problem. Maybe the problem of the model, maybe problem of the data set. So we need to come back. If you think as a problem of training model, you can just come back to training model and train another model and find, yeah, and test the performance. But if you think that is the problem of the data set, you need to, yeah, crack the data set again or clean the data set again. Just like you cook a very terrible dinner, and you don't know why that is terrible. So you need to maybe buy the food again, or just cook again if you have more food, just like this. And then the last step called mode deployment. Just like after cooking a vegetable, we need to put the vegetable on the dishes. So can you understand? And then we can use the model. Yeah, succeed here. So that is a process. Can you understand?
Yes.
Yes.
Okay, thank you. So how to evaluate or how to we need some metrics actually. We need some metrics to measure the performance of the machine learning model. And in classification task, just like the image recognition problem, and we can use the, for example, the accuracy or F1 score to indicate the performance. But before we calculate the accuracy, we need to know there's something just like P means the positive examples. That means all the positive data in the data sets, we have a lot of data. That is the ground truth reason. So all the positive data in data set, we can call it P. And the N is negative examples. And the TP means the true positive examples. For example, the ground truth label is right, and the prediction of the machine learning model is also right. That means true positive. But the ground truth is right, but the prediction is wrong. That means, oh, sorry. That means it's a false negative. And if the ground true is negative wrong and the prediction is also wrong, that means the true negative. And here, if the ground truth is wrong but the prediction is right, it called false positive. So can you understand? This table called the confusion matrix table. So that is a ground true. That is ground true, yes. And that is ground true, no. But it is a prediction. So if the ground true is yes and the prediction is yes, it will be true positive, just as I mentioned before. So we can use a lot of metrics to measure the machine learning model in classification task. So for example, the accuracy. So do you know how to calculate the accuracy? It uses the true positive as the number of the true positive and as the number of true negative, and divide by all the data, the number of all the data. That is accuracy. Can you understand?
Yes.
Okay, and there's another one is very important called the record. It will use the true positive, the number of the true positive divided by all the positive data. So why we need the record metric? It depends on the tasks. What do you want? So for example, in medical image recognition task, if the people is sick, actually that is sick. It means the ground true label is positive, but the machine learning model think it's normal. That means the false negative. The number of false negative, we hope it is very, very small because it's very harmful. Can you understand?
Yeah.
So we can use the record to measure the performance of the machine learning model. And when we, okay, that means we don't need to, we don't need to care about maybe some normal, some person is normal. Oh, sorry. But the machine learning model think maybe the people is sick. That means the false positive. That is not so harmful. It's fine because we should, we should give the positive cases to the doctors, for example, and the doctor will do the decision finally. So it's not so harmful. And then we can use the record. So can you understand?
Why is it called recall? I don't understand why it's called recall, because recall means memory or something.
Okay, the record can also call the true positive rate, and we can also use the record to indicate. So the true positive rate or the record rate, we use TP divided by P to calculate.
Okay.
And another one called precision. So what time we need to use the precision? For example, we buy some. Sorry.
I thought recall was true positive over number of true positive plus false negative. I'm not sure whether that formula is correct.
Yeah, here you can use the true positive plus false negative to indicate the number of the positive. That is same. Just here. It is positive, and you can use the true positive plus the false negative to indicate the total positive number.
Okay.
Yes. Okay. So I will introduce the precision. So what kind of tasks we need to use the precision? For example, when we go to supermarket and buy some watermelon. So do you know what is the watermelon?
Yes.
Kind of
Yes.
fruit. Okay, just like this. Yeah. Do you like my drawing?
Yes.
Okay. Yeah. Okay. So that is the watermelon. So if we hope to buy some watermelon, yeah, we need to use the precision to measure the performance. Because we don't need to recognize all the good watermelon. The good watermelon means sweet and fresh, for example. And we don't need to recognize all the good watermelon because we will only buy 1 or 2 watermelon. But we need to guarantee that this all of the watermelon we buy should be good. That is a precision. So we can use true positive divide by true positive plus false positive. So the true positive means the watermelon we buy, and that is a good watermelon. And the false positive means the watermelon we buy and the watermelon is not so good. So that is a precision. Okay, can you understand?
Yes.
So the false positive is very harmful when we buy the watermelon. And we hope the false positive is small. But the false negative, we don't care about it because we only buy 1 or 2 watermelons. So can you understand? We don't need to care about the false negative, but we hope the false positive is very small. Okay, so if we need to consider the recall and the precision, we can use the F-score. So the F-score will calculate by 2 multiply precision multiply recall and divide by precision plus the recall. And we can also use some constant here, yeah, to replace the 2 here. Okay. So can you understand why we need accuracy, why we need the recall, and why we need the precision?
What is the recommended value for F-score for you to say that it's good or it's bad? The range of the F-score.
So sometimes we need to think about the recall value and the precision value together. We can use the F-score just like this. That is the F-score. And maybe we can use the accuracy and the F-score together to measure a machine learning model.
So the F-score, is it a figure from 0 to 1, or is it a percentage?
Yeah, of course. The range of the F-score is 0 to 1.
So, and now, what do you consider good? Between 0 and between 5 and below, or between 5 and above?
Sorry, can you? What's your question?
Which score shows?
It depends on the task.
Yeah, it depends on the task. Okay. Some task, yeah, for example, the medical image recognition task, we will use the record. And when we buy the watermelon, for example, we can use the precision. And some tasks, yeah, we need to consider the record and preset together. We can use the F-score. And sometimes we can just use the accuracy. It depends on the task. Okay. Okay, so that is the example how to calculate the precision, record, and accuracy. Just find, yeah, that is a TP, and that is a FN. That is a FP. That is a TN. So I think you can calculate by yourself. Okay. So that is a P, that is a N. So do you know how to calculate the precision? Just use here, 140 divided by 140 plus the 20 here. Okay. And all of the precision, record, and the accuracy, the range of all of them are between 0 to 1. Okay, so there's a quiz, a single choice quiz. A machine learning model performs well on training set, but performs better on testing set. What problem might be happen?
Fitting.
Sorry?
Overfitting.
Overfitting.
Yeah, yes, exactly. Overfitting. Good.
Question.
Please.
Do you have an example of a multi-class matrix, confusion matrix?
Here. You want to know the example?
Yes, instead of just yes, no, maybe we had like 3 options.
Okay, yeah, there are binary classification tasks. If you want to do the 3 classification tasks, you can use micro precision or micro precision, but it is very complex. You can just Google it. But if you use the some framework, for example, there's a framework called sklearn. You only need to define the metrics like the micro precision or micro F-score. So the precision here is only used to binary classification task. Okay. That is very complex. So if you are interested, we can talk about after class, or you can just Google it, the micro one. Okay. thank you. So let's take a break for 10 minutes. I agree.
Yes.
Okay, so let's come back. 12.
That's fine.
Okay, thank you. Hello, my friends. Do you come back?
Yes.
Okay, so let's start. And then we will talk about the machine learning algorithms. At first, we need to know the tasks of the machine learning models and how we can use what method to learn the machine learning models. So we can think a machine learning model is just a function, like the function in Python, that is a function. And the input is the X, that means the data set, the data, and the output is the Y. So do you have any question about the function? And we just want to find a good function, and when we input the data and predict the output Y, so we can think a machine learning model is a function. And according to the output, we can divide the machine learning tasks into classification task. For example, the face recognition, and the regression task, for example, predict the price of the apartment, for example here. And the clustering tasks, that means we hope to put some similar data sets together. Yeah, put some similar data sets together, that are called clustering task. And the last called the structured learning task, or we can call it the generative task. For example, the machine translation, we need to translate, or we need to create a sentence. Or the image super resolution task, we need to create a clear image. So that called structured learning task or generative task. Okay, so the first one I want to introduce a classification task. So what kind of the output can be a classification task? And for example, if we input a burger, do you know what's the name of the burger? Do you know what's the name of the burger?
Double burger, I think.
It's called Big Mac. Big Mac. So do you know the McDonald's?
Yes.
So yeah, it's the burger named Big Mac. So if we today input a Big Mac, and we hope the machine learning model can output the class of burger. So that is a classification task. And how to indicate the class? We can use a vector, and the vector, each dimension of the vector means the probability of each class. For example, the first dimension means the probability of the burger, the second dimension means the probability of the French fries, and third one maybe means the probability of the rise. So that is the probabilities. And we will choose the highest probabilities as the last class. So we will change, for example, here, the probability is 0.8, 0.1, 0.1, and then we will choose the highest probability and change to 1, 0, 0. It will be a one-hot vector. That means only one dimension will be 1, others will be 0. So that means the classification, the class 1, and that means the class 2, and that means the class 3. So this task, we do the 3 classification task. We can use one hot vector as a output. So can you understand it?
Yes.
Okay, but when we do the binary classification test, we can also use one scalar, one value to indicate the result. But we need to limit the output, the range of the output from 0 to 1. The 0 means the negative, and the 1 means the positive. So if the probability is 0.9, that means there are 90% probability of the positive. So we will change the 0.9 to 1. That means the prediction is positive. But this can only use in the binary classification task. So can you understand?
No, do you mind
problem?
repeating that, please?
Okay, so we can use one hot vector to indicate the class. But if we do the binary classification test, that means there are only 2 class, the negative and the positive. And we can use 0 to indicate the negative and 1 indicate the positive. And the output can be only one scalar, the range of the number between 0 to 1. That means the probability of the positive. So for example, the output is 0.9, that means 90%. The machine learning model thinks there's 90% is the positive class. So if we do the binary classification test, we can also use one scalar or one number. Okay.
The example is 0.45.
45? Yeah, we can set a threshold. For example, if the probability smaller than 0.5, and it will be negative. And if the threshold we set, for example, 0.3, and if the result is smaller than 0.3, and it will be negative. Otherwise, it will be the positive. So if we hope the record value, we need use the record value to measure the machine learning model. We can set the threshold higher, for example, 0.9. So can you understand?
Yes, I understand.
Okay. So thank you. Okay, that is a classification test. Oh.
So
sorry.
is this a case of a multi-class classification problem?
Yeah, that is the example case. oh, sorry, that is a mistake. If we hope the recall is higher, we need to set a small value of the threshold, for example, 0.2 or 0.3. So if we hope, yeah, the precision is higher, we can set a big value. Sorry. So what's the question? Do you have any question about the classification task? Okay, let's go on the regression task. So if now we input the Big Mac and we hope now how many calories of the Big Mac, we can think that is a regression task. So the output of the regression test can be a value or scalar, and this number is continuous. That means there's a meaning if we use 100 to minus 400, it will be 100 calories. That means the number is continuous. So there's a question here. If we want to recognize if the phone uses 3G, 4G, or 5G, so do you think what's the task of the machine learning? So if we hope to know the phone use 3G or 4G or 5G, what's the type of the machine learning task?
Is still classification?
Classification.
Classification.
Yes, exactly. That is the classification task. Because there's no meaning when we use a 5G minus 4G. What is 1G? There's no meaning. So that is not continuous. If the result is continuous, we can think that is a regression task. Okay, can you understand? Yes. Okay, thank you. And next one called clustering. So if we input all the food in McDonald's and we hope, yeah, we can cluster the hamburgers together. That called clustering task. There's a model called K-means, a machine learning model, and can do the clustering task. So it's just like something similar. We put them together. It's called clustering task. I will give you an example later. Okay. And the last one is structured learning task or the generative task. That means if we input a lot of pictures of the hamburgers, we hope the machine learning model can draw a new burger. This burger is in KFC. So we hope the machine learning model can draw a new burger. We can call it as a structured learning task. There's an example, just like machine translation. If the output is a sentence, the sentence is also called a sequence, or the matrix, that means images. Okay, and so on. We can call it as structured learning. So what's the difference from structured learning and ask tasks? Because between pixel and pixel, there's some relationship between pixel and pixel in one image. So that is a structured learning task. So we cannot use this pixel and other pixel of other pictures and combine them together. There's no a whole image. So if there is some relationship between pixel to pixel or words to words, for example, the translation task, that we can call it the structured learning. Can you understand?
Yes.
Okay, thank you. So there are 4 tasks, and there are also 4 learning methods in machine learning. And we can, according to the input X, and we can divide the learning method into supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. The supervised learning means the data has labels. For example, the class or the price, we have the ground truth labels. But the unsupervised learning means all the data has no labels. And the semi-supervised learning means part of the data have labels. And the reinforcement learning means the label is the reward or punishment. So I will give you some examples here. So that is unsupervised learning. And there are 3 features of the data: the weather, temperature, and the wind speed. And we hope to predict if the weather suitable for sports. Can we enjoy the sports in this kind of weather? So there are some labels for each data. This row means one data, and the data has a label yes, and this data has a label no, and this data has label yes. So all the data has labels. We can use a supervised learning to train the models. So can you tell me what is the task here?
Classification again? Classification.
Yes, classification again. Okay. So according to the labels, maybe we will find some regularities in the futures. For example, if the weather is sunny, and the machine learning will find the regularities. If the weather is sunny, the label will be yes. The answer will be yes. So if the weather is raining, it will be no. Just like this. It calls supervised learning. We have labels. And the unsupervised learning means we don't have any labels. But we can also do something. For example, the clustering. We can put something similar together. For example, the badminton racket and the basketball, both of them belongs to the sport. Yeah. So we can put both of them in the area of sport. For example, in supermarket, we can put these 2 items together and into the area of the sport, and then the customer go to buy the basketball. The customer will find the areas of the sport first and then find the basketball. So that is an example of unsupervised learning. We don't have the label, but we can put something similar together. And that is a game, so the game then belongs to the sport, so we will put the game into the class 2. It's just the example. And then semi-supervised learning means only part of the data has a label. So for example here, the weather and the sports again, and only the first data has a label yes, but the second one and third one we don't have the label. So how to do the semi-supervised learning? One method is we can do the unsupervised learning, for example, the clustering first, and then we do the classification task. For example, we can put something similar together For example, the first one and the second one, both the weather are sunny, so we can put them together. And here, the first one has the label yes, so we can guess maybe the third one also the label is yes. And then we can do the classification test because we can fill some labels by ourselves according to the class string result. Okay, can you understand?
Yes.
Okay, thank you. So the last one called the reinforcement learning. We know in AlphaGo, we use the reinforcement learning. So what's the difference between reinforcement learning and the classification and the supervised learning, sorry, and supervised learning? Yeah, for example, when we do the examination, and yeah, the teacher gave us all the answer for all the questions. It called the supervised learning. So we know all the answer of questions. It calls supervised learning. But if the teacher only give you the score of the examination, only give you a score of the examination, it called reinforcement learning. So why the teacher doesn't give you the answers? Because in some tasks, there's no standard answers. We don't know the best choice of the first step. But it's easy to know win or lose. So if we win the game, we can get a score 1, and if we lose the game, we can get the score 0. So it's easy to get a score, but cannot get the answers. And then we can use the reinforcement learning. So the agent, for example, here is AlphaGo. Sorry, it's AlphaGo. And the AlphaGo play one step, and the board will be changed. So here, the board is the environment, and the environment will give the AlphaGo a new state. And then the environment will also give the AlphaGo a reward or punishment. That means if the AlphaGo win the game, it will give reward 1, or if the AlphaGo lose the game, it will give the punishment, means 0, for example here. So that is a reinforcement learning. There's no answers, but the machine can only get the score. So can you understand?
Yes.
Okay, thank you. So let's do a short summary. According to the label of the input, we can divide the learning method into supervised learning, unsupervised learning, semi-supervised learning, and the reinforcement learning. And according to the output Y, we can divide the machine learning task into classification task, regression task, clustering task, and structured learning task. So if we use the supervised learning to do the classification task, and for example, the face recognition task, we can just use the supervised learning to do the classification task. For example, when you want to use your face to unlock the iPhone, you need to store the feature of your face before you use the Face ID. So do you know what I mean?
Yes.
So when you store your feature, thank you. When you store the feature of your face, And at the same time, you will tell your iPhone, remember that is my face. And at that time, the data have the label that's your face. So it can do the supervised learning. And of course, the face recognition task is a classification task. So it uses a supervised learning to do the classification task. Okay, and the AlphaGo uses the reinforcement learning to do the classification task. It will select a best choice of each step. So can you understand? Okay, there's a quiz. What learning methods are most suitable for board games, agent, for example, the chess or the Go?
Reinforcement.
D.
Yes, D, exactly. So we don't know the standard answer. We don't know what is the best choice of each step, so we cannot use a supervised learning. It will not perform us very well. And yes, if we can use the reinforcement learning because we can easily to get the score. We can easily know we win or lose the game. Exactly,
Question.
reinforcement learning. Yes, please.
Question, can you put all the previous chess games for 100 years to make it choose the best move? In other words, you make it supervised learning.
Yes, you can do that, but you need a lot of data sets. Actually, in AlphaGo, the first version of the AlphaGo,
yes,
yeah, it will do the supervised learning first.
Okay.
Use a lot of data set for
games.
a lot of games.
History games, yeah.
Yeah, and do the supervised learning. But it will not perform us very well. If
Okay.
you know, yeah, the AlphaGo 0, it will never use the supervised learning, but only use the reinforcement learning. And the AlphaGo can beat the first version of the AlphaGo. The AlphaGo 0 beats the first version of the AlphaGo by 100 to 0. So, yeah. So.
What?
Yes.
That's really a range.
Yeah.
So, you know, so can you understand why the AlphaGo 0 can beat the AlphaGo? Because it only uses the reinforcement learning. It's suitable for the board game. Okay. Yeah. So let's see some machine learning models. The first one I will use a long time to introduce, that are called linear regression. So that is a linear regression model. The Y, or sorry, it can use fx to indicate. Yeah, the machine learning model will get the result by multiply the weight and the features of the data sets, and then plus B. For example, there's only one dimension feature. There's only one feature. For example, the X is only a number, and then the W will also be a number. So for example, 1 multiply 2 and add 3, it will be 5, right? So that is a linear regression. Yeah. Okay, so that is a linear regression model. So that's right line in case a linear regression model. But if now we have a lot of features, for example here, there are 3 features of human, the weight, height, and age. And then that means the dimension of the X is 3, right? We need to use a vector to store all the features. And in this time, the W will also be a vector. So do you still remember the operation of the vector? I mentioned in math class. It means dot product. It means if we multiply the W and the X, it will be a value. That is a scalar, and the B is also a scalar, of course. And then we add these two values, we can get the final result. So here's a question: how to evaluate the linear regression model? We know the linear regression model do the regression task. So how to evaluate? We need to use a loss function to evaluate. The loss function is we can call it MSE or two loss function. And it will use the prediction value minus the true value. That means here, maybe we use -1 or 1 minus 1, the weight. That is a weight. -1, 1, -1 and the bias is 0, okay. And to predict this data, it will get get 80 maybe, right? It will get 80. So we will use the 80 minus 120, that is the ground truth label, and power 2, and multiply 1 second. That is a loss function mean. If you can understand, you just remember we need to use the MSE or F2 loss function to do the regression task. Okay, and then I will show you the experiment. Okay. Okay, just open the TensorFlow experiment and let's see the linear regression example. Okay, so there are two parameters here. The first one called W means the weight, and the second one called B, that means the bias. So in linear regression, we have two kind of parameters, and the target of training the model, we need to find a group of W and B. We will find, or we will calculate the group of the W and the B. That means a good W and B, we can get a good linear regression model and predict a task very well. So in this task, we can run it first. We will predict the price of the apartment, and we only choose one feature that called the area of the apartment. Here, there's an example of the table that's first data, And there are a lot of features. Just to remember, before we train a models, we need to select the features. So now we can select only the value. Here, we only care about the value, this column, and predict the area, this column. So here, the area is the Y, the output, and the value is the input. So we need to define the learning rate, because when we train the linear regression model, we need to use a gradient descent. So do you know what is a gradient descent? Maybe not. We know we have the loss function, it's called L2 loss function, and we can calculate the loss value. And the gradient descent means we use the partial loss to partial weight to calculate the gradient. So do you know the partial loss to partial weight? Maybe not, but you only need to remember the partial loss to partial weight means if we change the weight a little, for example, change the weight to a very small value, and then the loss will also be changed a little. For example, if we use the old W equal to W minus the learning rate, multiply the partial loss to partial W, and we will get a new weight. And the new weight will change the loss smaller. Change the loss be smaller. And that is a gradient descent. Just like there's a mountain, and we hope to go down the mountain, but we don't know the direction. We can only follow the gradient here, step by step, to find how to go down the mountain. Here, the X means the weight, and the Y means the loss. So we need to change the loss. We need to change the loss to smaller. That means the prediction value and the ground truth value is close, and the loss will be small. So we hope to training the linear regression model by change the W and the B. Okay. So here we need to define the learning rate. That is how much we update each time. If the learning rate is very big, we can train the model quickly, but sometimes if the learning rate is too big, we cannot train the model. Yes. Okay, and the epoch means how many times we train the model. And okay, we need to use the variables to indicate the weights and the bias, because we need to change the weight and bias by each training, in each training. So let's run the program. And here, the prediction, just multiply the W and X and add the B. It will be the prediction. And the cost we use, use a prediction value minus the true value, that is Y, and power 2, and then divide by 2, multiply the number of the samples. Or we can also ignore this item, because that is a constant. That is only a number. Okay, and then we can use the optimizer The optimizer I will introduce tomorrow. Yeah, here you need to know the Aiden optimizer use gradient descent method, and we need to set the learning rate and to minimize the course. And then initialize all the variables and train the model. Look at here. That is the model we trained. The blue line means the linear regression model we get. Okay. The red point means the data. So if today the model like this, very complex and equal overfitting, right? Okay, that is a linear regression model. So
this learning rate, I saw you put 2. Where does the 2 come from? And what is the range for learning rate?
The learning rate, we need to set the learning rate by ourselves. We
So
can
how do
use.
You know 2 is a good value. Can it be 100?
Good question. Good question. We cannot use very big learning rate. You can change it to, for example, 2000. You will find the loss will go up, will be large after each training. And you can find, for example, here, the cost will be bigger after 10 training. After 10 step will be bigger. Why? Because we set a very big learning rate. The 2 is very big. If you change the 2 to 0.02 and use more steps, for example here, and okay, I will train it again. I will show you. Look, it will not go up. It will go down step by step, very slowly, but it's not easy to go up.
Okay.
Can you understand? So we can set the learning rate small at the beginning. And if you think that is too slow to train, especially in your networks, it need a long time to training. So you find the training speed is too slow, and we can change the learning rate bigger. Okay. Yeah, thank you.
And someone used the grid search to automatically to find the most appropriate parameters, values.
Yes, I will introduce tomorrow. The Aiden optimizer will change the learning rate actually. So I will introduce tomorrow. You can use other optimizer to change the learning rate during the training. Okay. Actually, here the learning rate will be changed during the training because we use Aiden. And if you hope to search the initialized learning rate, it's very difficult, but you can do it. If you're interested about it, it's called the meta learning. We can also call it learn to learn. Just use another machine learning model to find a good learning rate. It's called the meta learning. Yes, you can just Google it if you're interested. It will do the auto learning, just find a suitable learning rate, for example. It can also find a good initialized weight or bias. So that is the meta learning. Okay, can you understand? Use another
I
machine learning model.
Question. I had another question.
Yes.
The training data, I thought it's one data set. So I don't understand when you say the model runs several times. I thought it will run only once with that single data set. Where will the second run come from?
Look at here. There is 4 loop sentence here.
Yes.
Yeah, it will.
Oh yeah, there's a loop
it
within
will
a
set
loop.
the epoch.
The epoch.
Yeah, here we set the epoch here. A training epoch will start to 0 to 1000.
Okay.
Yes,
I
it
missed
will
that. I
train.
came late.
Okay.
No
So
yeah, thank you.
You're welcome. So do you have any question?
It's okay now.
Okay, so let's go back. We need to speed up. Maybe we can learn other model. Oh. Okay. Yeah, another model I want to introduce called logistic regression. But attention here, the logistic regression model actually do the classification, the binary classification task. The name cheat us. Actually, the logistic regression model can only do the binary classification task because it uses a sigmoid function. So after we get the prediction of the linear regression model, we will put the output into the sigmoid function that is here. The x here means the input, and the y means the output. So the linear regression model, or logistic regression model, sorry, the output will between 0 to 1. Can you understand? Because we can use the sigmoid function. That is sigmoid function. That is a linear regression model. Do you still remember? And we just put into the sigmoid function. That is a sigmoid function. The x means the input of the sigmoid function, just like this. And the y means the output here. So the output of the logistic regression model were between 0 to 1. And do you still remember that we can do the binary classification task? That means the probability of the positive class. That is a sigmoid function. We don't need to know that, ignore that. So you only need to remember the logistic regression model, we do the binary classification task. Okay, but we need to use another loss function. It's called cross entropy. We often use the cross entropy in the classification task and use the L2 loss function in the regression task. You need to remember that. So if you are interested about how can we get the cross entropy, just take a photo of this slide, and I will not introduce the detail. Okay, so you only need to remember the difference between linear regression model and the logistic regression model. That is, the linear regression model, we don't need to use the sigmoid function, but the logistic regression model, we need to use the sigmoid function in the output, and then change the L2 loss function to the cross entropy loss function, it will change the linear regression to the logistic regression. And the linear regression, we can do the regression task. And the logistic regression model, we can do the binary classification task. Okay. And then the decision tree. Oh, the time is limited. I will introduce the decision tree briefly. Maybe we can continue tomorrow. Okay, so what is a decision tree? The decision tree, just like we need to build a tree. And the node here, called the root node. Here, also another row node. And here, we can call it the leaf node. And in the root node or some purple nodes, we need to put the features and input the features just like the age and look and others of human. Yeah, and we will judge the features just like if the age is smaller than 30, and okay, I will see again. And if the age is bigger than 30, I will reject. So what is the task? Or maybe judge if I will meet a girl, maybe. So if the girl is the age is bigger than 30, and I will reject. And the age is smaller than 30, and I will consider. If the look is ugly, I will reject. Maybe no, it's not me. And if the look is beautiful, and I will consider again. And okay. If the girl is rich, I will meet, and if the girl is poor, I will reject. And if the girl is still, do you know what was that? That is a job in China.
Government job. Government job.
Yeah. Okay. Yeah, and then I will consider the last node. So that is a decision tree. So what is the advantage of the decision tree? It can fit all the training set, because we can build a very large tree, and we can use a lot of leaf nodes to fit all the training set. But for example, the logistic regression model, we cannot fit all the training set, but we can use a decision tree, a varied tree, to fit all the training sets. But if the model learn very well in training set, the decision tree will easy to overfit. You understand? The decision tree will easy to overfit. And another advantage is the decision tree can explain why I reject the goal. So it's easy to explain. But if we use the neural network, it is very hard to explain. So the neural network, just like the blackboards, and we only care about the input and the output. So it's very hard to explain. Okay, but if the tree is too big, for example here, there's the one guy proposed a question. Oh, my decision tree is too big. Can you help me to explain? And after 3 years, and no one replied him. Do you know why? Because it's too big. Do you want to help him to explain? I will not. So if the decision tree is too big, it will also hard to explain, but sometimes the decision tree is easy to explain. That is an advantage. Compared with other models, it's easier to explain. Okay, and that is all for today. And tomorrow we will continue to introduce support vector machine and naive Bayes model and k nearest neighbors model, and then we were going to learn the deep learning. Okay.
Okay.
Okay, thank you.
Sir, I have a question.
Yes, please.
This Stockfish app, it uses which type of learning? Is it reinforcement? Stockfish, the chess game.
Stockfish?
Yes.
Stock?
Yes, Stockfish, or it doesn't use machine learning.
Sorry, I don't know what is a Stockfish, but
It's a chess game.
Okay, it's just a game.
Yes.
I did not play this game.
Oh, okay, sir. Okay, okay.
If you want to use the machine learning model to play the game, I suggest you use the reinforcement learning.
Oh, okay.
Because the game can also give the feedback, for example, the reward or punishment. For example, in this game, you get a very high score, and in another game, you get a very low score.
Okay.
So you can use the reinforcement learning to do that.
Okay. And one more question. What is a binary value we can give for 0.5 probability, 0.5 probability?
0.5?
Yeah, because if it is less than 0.5, we can say it's 0. If it is above 0.5, we say it's 1, isn't it?
Yes.
So, yeah, if it is 0.5, yeah.
Yes.
What binary value we can give?
You can set.
Okay.
Yeah, it's both fine in 0 or 1. You can set.
Okay.
It doesn't matter.
Okay.
And
Okay.
you can also set a threshold, for example, the 0.3.
Okay.
Here. Yeah, you don't need to use
0.5.
0.5 in all the tasks.
Okay, thank you.
Yeah, you're welcome. So, do you have any question? Okay, it's all for today. See you tomorrow. Bye-bye.
Okay, bye-bye.
Bye-bye. You're welcome. Bye-bye.
Bye.